we just said is that today is the final piece of the puzzle, final component of the infrastructure we're building. We've got the ESXi, the virtualization workhorses. We've got the vCenter, which is the management server. We talked about virtual networking and connecting them together. And today we're going to look at the storage, which is the final piece before we look at the features of vSphere. The advantageous features such as the vMotion, such as the live migration, which is live migration, such as the such as the high availability and such. Okay, so what we're talking about is that these in this picture, what is described, Hong's left anyway. So I'm here taking time to explain it. She's left. Okay. I can hear you now. You should have mute yourself. I don't want to be here anymore. Okay, stop talking, Alex. That's what she said. Okay. So just to reiterate, we're using the CPU memory here and the networking. We're using the storage here. We said the amount of storage or amount of memory, is if we compare it, the amount of memory we give to a virtual machine, about 4 gigs, right? But if we look at just a simple virtual machine, which I've configured as a domain controller, that's 13.8 gigs. That's not even a production server. That's just a basic nothing server. Okay, so that's 13 gigs. So if you think about it, if I had to transferring data, 4 gigs or 13 gigs, obviously the 4 gigs is a lot faster, isn't it? So basically, if we think of this as where the virtual hard disk is, this is where the 13 gigs is, and this is where the memory is, and the memory is not, everything's not useful, okay? It's only what's being used at the time is useful. So if I've got my storage here, if I want to move this VM from here to here, all I have to do is transfer what's in memory. And I say it's 4 gigs, but that's the maximum. It depends on how much is being used right there. And it's also, we just transfer the memory over, and then we have a sort of a virtual machine that's running here, but not really active. And then once we keep on synchronizing the memory until it's almost exactly the same, then we just switch over. And basically, assuming that these are all connected to the right networks, this virtual machine will still continue to operate exactly the same. And as far as the user is concerned, if this is a web server, it might take a couple of more milliseconds to load the web page. Okay, you'll see when we do the lab for the vMotion, we will do a continuous ping to the virtual machine, and you might see we lose 1 ping packet, 1 ping request. Okay.
Sorry, just to clarify, even the virtual machine folder is stored on shared storage or on the same device?
It's here. This is the SAN. Okay, this is the storage device. So it could be a SAN, could be a NAS, could be lots of different things. But it's the key thing is all the virtual machine storage is here. Okay, it doesn't matter what you think of, the hard drive, the configuration file, the folder, whatever. Okay, everything is here. All right, so basically what I'm trying to say is if it's here, we don't need to transfer that. It just sits here. So we just have to transfer the little bits and pieces and we can get live migration. All right, the second thing is if this virtual machine is running here, okay, it's working, and this device fails, just some breakdown, okay, whatever. The network cable is pulled, the power supply explodes, whatever, doesn't matter. But if you remember, we talked about a heartbeat. I am alive beacon. And if we stop receiving the beacon here from this host, then we can assume that it is dead, if you remember. And then we know from our VMware vCenter what virtual machines we're running here. And if some of them are critical, then they might be protected by what we call high availability. So once we actually realize that this host is no longer functional, all we have to do is tell the virtual machine to be started on this host or this host. And you know, the beauty of it is you don't have to try to recover the files from here, because the files are already here, and these ones all can access it. So I just tell it to turn on here. So that's pretty much like that, isn't it? You'll still have downtime, but it's better than trying to, oh, this is dead hardware. I need to take the hard drive out, or I need to do this and get the files off and then put it here, then turn it on. You can see how that's a lot more time consuming. And the best thing about high availability, you'll learn later on, is that it is automatic. Because of the heartbeat, we can detect it, and we can automatically, if it's protected, start it elsewhere. All right. And there's many other reasons why we have shared storage. And basically all your, the interesting features, all your good features that you want to have in your virtualization environment does not work if you do not have shared storage, okay? So it's critical, okay? So VMs depend on the shared, depends on the performance of the characteristics of the underlying storage. So we all know that. If we have hard drives, like we've been talking about, we basically, if we have 6 virtual machines running, they all share the input-output functionality of that particular hard drive, right? That's why we want to get the SSD, because it's got high I/O per second, input-output operations per second. IOPS, you might have heard of that term. We might have discussed it, okay? So if for anyone who doesn't understand, just in case, if you want to think about it, think about, anyone go to church here or temple or something like that? No? Don't worry about that then. Anyone go to the concerts and football games?
Ed Sheeran.
Yeah, Ed Sheeran, yeah. On Tuesday there was Ed Sheeran. So my family went, and they said there was so many people. They wanted to go to a restaurant afterwards. Okay, but it was full. Yeah, so basically when they get to a restaurant, and if you have one person at the counter taking orders, let's say it's McDonald's, okay? And let's say 20 people come. If I'm the only person taking orders, the person who's right at the back of the line is going to wait a long time, aren't they? But if you think of that as the IOs per second, how many things I can do, okay? And if you think of you guys as the virtual machines, and you wanting to read and write to the hard drive, you have to wait until I can ask you what you want. And that if you're right at the back of the line, that might be a very long time. The more IOs per second we have, it's like the restaurant, instead of having me, one person at the counter at McDonald's, you have 5, 6. You can see that the person who's at the back of the line of the 20 people line will get served a lot faster, wouldn't they? So that's the difference when we have more and more IOs per second. So when we are sizing and designing the storage solution, you focus on the capacity and performance. Okay, capacity is one thing. We all know about the more capacity, the better, the more files we can store. But that's not for virtualization, that's not the number one priority, okay? Number one priority is not how much you can store, it's how fast they can perform. So it's measured in bandwidth, megabytes per second. So obviously we need to, if these virtual machines are, wrong screen. If these virtual machines are actually stored here, every time they need to write or read from the hard drive, they must communicate through the physical layer into the physical network, into this SAN, and tell it to read or write. And if it's transferring a lot of data, it's passing all that data through here. So this connection must be very fast. Okay. Secondly, we talked about IOs per second. Like I said, even if this is very fast, if the disks themselves don't have a high IOs per second, then they can't actually service all the requests that's coming not just from one virtual machine, but from 6 here, 6 here, 6 here. Let's say that's what's that? 18 virtual machines just in this example, right? So they can't service them. So they must have high throughput. And obviously, if you don't have high bandwidth and high throughput, you'll have you will have more latency. If you don't know what latency means, it's lag. Okay, if I want to do something, it's like if you have kids and you guys have your kids, you tell your kids go wash the dishes, and they just sit there and they do nothing. They wait 5 minutes before they even get up, and you get frustrated, right? So that's latency. That's a 5-minute latency where you tell your kids to go wash the dishes, and they actually go wash the dishes. Okay. All right, so let's talk about local versus shared storage. So we're all used to local storage. Local storage is the hard drive that's inside the device you're using as the host. Okay, so So those ESXi that we've got, that we've configured, they have a local hard drive, right? That's the local storage. So ESXi has many storage options. You can have local SAS, SATA, SCSI, okay? And you can also have fiber channel over Ethernet, iSCSI, and NFS with NAS and InfiniBand. You guys gonna question me at all here when I say local storage?
Yeah.
Yeah, are any of these local?
No.
They're not really local, are they? So the key thing is they're not local. These are the local ones. These are the local connections. Okay, you can't connect the physical hard drive directly to your motherboard through fiber channel. Okay, but you can with SAS, you can with SATA, you can with SCSI. But the key thing is it's not. These ones are really used in shared storage.
Yep.
Okay, so ESXi has many storage options. The first one, these ones are local storage options. These ones are shared storage options. Local storage is limited as many many vSphere's advanced features such as vMotion, high availability, DRS, and fault tolerance require the shared storage. If you don't have shared storage, none of those things work. With vSphere auto deploy and the ability to deploy ESXi images directly into RAM at boot time, so we discussed that in one of the first lessons. So we don't even have to install onto a hard drive. We can just run it from memory. Okay. Couple that with the host profiles to automate the configuration. In some environment, local storage has little functionality. Okay, so what does that whole point mean? If we have shared storage, we could so let's open up a browser. Let's look up some pictures. So if we have a look at this idea of blade servers, all right. So basically, if we look at blade servers, this guy is just let's go look at what he's doing. So blade server is basically a chassis. Okay, so that's just a box, and each one of these is a different server. You can see just by the size of it, it's not very big, is it? Okay, and they can be much more thinner than that even, and much more smaller than that. You can see that's not very big. So, and you can see that you can just put more and more. See, these ones have servers in them. These ones are blank. So we can take the blank ones out and add more servers. But if you look at the size of it, do you think there's many hard drives in there?
I suppose all the hard drives underneath.
Yeah, so the whole point of this blade servers is for virtualization. So we can have a lot of CPU, a lot of memory, a lot of network resources like we talked about, but we don't have to put the hard drives in here. Just imagine it, just so we can even have mirroring, so some sort of protection, we would have to have at least 2 hard drives in each one of them. I don't think it'll fit, to be honest, just by looking at that picture. In fact, we can go to extreme. What that last point is, we can go extreme. We can have 0 hard drives in here. 0 hard drive there, just full of RAM, full of CPUs, full of network cards, but 0 storage. And what that point was saying is that in the first lesson, we talked about how we can create images of ESXi. Okay, and when images of ESXi is stored somewhere on the network file server, let's say, if your computer was a ESXi host, when it boots up, we can use the auto deploy so that it boots from the network and download the ESXi image, put it into RAM, not hard drive, and run it in memory only. You get me? So all of the installation, we know the ESXi is a very small footprint, isn't it? If you think about your ESXi servers without any virtual machines on there, they're probably only 400 megs. Okay? So the ESXi itself is very small. So that can be all inside a RAM. So what does that mean? That means we don't even have any storage on the ESXi.
You can have ESXi with no storage on
with no storage itself, because we can use the network storage, which is what really that happens in the enterprise. Okay, shared storage is the basis for most vSphere environments because it supports all the VMs themselves and is required for many of the features we talked about. Shared storage in both SAN configurations. In SAN configurations, so in the SAN you can use fiber channel over Ethernet, or iSCSI. These are free SAN type connections. Okay, or you can have as a NAS. NAS is not preferable. Okay, NAS you can use what's it? NFS. You can use SMB, CIFS, which is no name for SMB free. Okay. So NAS is always highly consolidated. Consolidated means it's all put together. And this makes it efficient. So you don't have to spend money on each ESXi server. Like if we looked at that Blade server just then, we got 1, 2, 3, 4, 5, 6, 7, 8. Let's say we got 16 here. If we had 2 hard drives in each one of these, that's 32 hard drives. And that's not really even redundant, and you don't have that much storage. If we put the same 32 hard drives into a SAN, you can see that it's going to be a lot more efficient because we're not actually wasting any of the thing for just the mirroring. Because if we got the 32 and we did mirroring, that's already just 16 wasted, isn't it? So if we put the 32 in here, we set up some sort of a RAID 5 system or RAID 6 or something like that, we're not wasting as much, and it's still redundant. And now, instead of each one only using the capacity of the one hard drive because it's mirrored, we are using the capacity of all the hard drives together. Okay, makes it more efficient. Defining common storage array architectures. So external connectivity. So between storage array and the host is generally fiber channel or it's fiber channel or Ethernet. Okay, so fiber channel, if you don't get it, it's fiber optics. Okay, what do we know about fiber optics? It's very fast. It's lossless. So have you heard that term, lossless? It means it cannot be interfered with electromagnetic interference. So wherever you send, it's definitely going to get there. Okay, and it's going to be intact.
But the cable is expensive.
That's the downside. It's very expensive, and you need a special license to even just install it and to terminate it. So the average person can't do it. Okay, you have to get external contractors probably most times to do this. But Ethernet is cheap. On the other hand, right? It's cheap. Most people can do it, and you don't need a real license to do this. But you probably should get someone with a license to do it. And everyone knows it. Pretty much every network person knows Ethernet. Not every network person knows fiber channel. Okay, they probably not have much experience with fiber channel. And also InfiniBand. Okay, that's another option as well. The characteristics of this connectivity defines the maximum bandwidth. Obviously, depending on which one you choose, there's a maximum, there's a minimum, etc. Storage processors. The storage processor handles the I/O, input/output, and runs the array software. So basically, the storage server, the SAN, still has to have CPU, still has to have memory, still a computer. Okay, but instead of spread across many computers, it's just consolidated. Most modern arrays do not use purpose-built application-specific integrated circuits, or ASICs, if you heard of that term. Okay, but instead they use general-purpose CPUs. So if you like to think of it, most storage arrays are just big computers with lots of disks. Okay, they just run specialized OSs, specialized hardware. Some array.
Is that SAN Solaris?
Sorry?
What is the OS on that one? SAN Solaris?
Depends on which one you choose. You can even get Windows Server 2022 storage server option as one of those. It basically turns your 2002 server into a SAN. Okay, and then you can just use what's called JBODs. Let's you heard of the term JBODs? Let's define that term. JBODs. JBODs is basically it's another name for just a bunch of disks. Okay, which is a storage array here, like that. Okay, but instead of having a controller system like in the other SANs we're talking about, we just have a server 2019, 22, whatever version, storage server, and then they can control all of these as well. So let's not go.
Really just connected.
Yeah, so physically it's connected through wherever. Okay, it could be through the fiber channel, it could be through fiber channel Ethernet, could be iSCSI. That's something that's separate. Okay, you choose that first, and then controller can be server 2022. Okay, storage server. So let me just, for the sake of completion, server storage. So pictures probably here we go. So you can get a version of Microsoft Server, which is a storage server. You can't actually buy the storage server from the shop. Okay, it comes on hardware. You have to buy the hardware, and the software comes with the OEM. Can I help you guys? Oh, the classroom down there. Okay, no worries.
I haven't solved one of those server blades before. How are you, Alexi?
Yeah, I'm good.
You good?
Yeah.
Sorry about that, guys. Just helping the other students out. So, like I know we've sort of gone sidetracked yet, but let's just finish it off. So, your storage server can be server 2016 or 1922, whatever. It can be Linux. It can be proprietary hardware, software. So it depends on who you buy from. You buy a SAN from Dell, it might have their proprietary software on there. If like I said, with the server 2016 or 2019 or 2022, it's OEM. Okay, you buy this hardware, it has this on there. As a normal IT person, you can't buy this off the shelf. You have to be an OEM, original equipment manufacturer, to actually have that.
And which one is more efficient for the?
Depends on what your expertise is. Okay, which one? It depends on what your expertise is. Like, which one would I choose? If I have all server 2000, Microsoft servers, then I might go with the Microsoft solution. If I have a mixture of Linux, Windows, or maybe all Linux or something like that, I might go with the proprietary solution or a Linux solution, but it's really depends on your expertise. Okay, so I would in general go with the proprietary. So like, as in, if I go to Dell and I buy SAN, the software comes with it. As long as using the right protocol that's compatible with mine, then I'll just use it. Okay, but the key thing is, if you want to, you can go and get Microsoft Server and turn that into a SAN controller. Okay, that's the key thing I'm trying to emphasize here. But which one would I get if it was my money for my company? I would buy the one that's come from. No, no, stop saying that. Make it sound like I'm a Microsoft lover. Which, if you look at all the subjects I teach, you're probably right. but it's best solution for the situation. Okay, so that's my philosophy. But let's keep on going with this. Okay. So the array software, although hardware specifications are important, you can define the scaling limits of an array just as important as the functional capabilities of the software provides. So basically, the array software is where we're talking about the proprietary software, the Linux version. So a lot of NAS, you know, is Linux based. The proprietary software that comes from the OEM or the Microsoft server. Okay. The capability of modern storage arrays are vary and vary wildly amongst vendors. So you have to assess each one and see if they support what you want to do. Okay, if I want a fiber channel and I go and buy hardware which has got fiber channel, and the array software can handle the amount of disk I have, the redundancy level I want to have, and then it doesn't matter which one I choose because they're all working to a standard. You guys all understand standards, right? If they're all working to a standard and my other things working to the same standard, they can work together. If this doesn't support, like this only supports, let's say, NFS, because I've got NAS, it only supports NFS, SMB, and iSCSI, but it doesn't support fiber channel over Ethernet, then this is what I want. It doesn't work, okay? All right, so the array software gives us the functional capabilities. So we assess the functional capabilities, the remote storage replication. So some of the things we might want to think about is remote storage replication. So just because we have one site, okay? So if we talk about TAFE SA, if we have all our services hosted on Adelaide campus, because that's our main campus, what if there's a power outage to the whole of the campus? Does that mean all your services go off? What if the whole campus burns down? Okay? What happens to your servers and your data? So just like what we do with data, we will back it up and replicate it. We can also replicate our SAN from one site to another site. So all we have to do in a situation like that is to have some capacity at another site, and we would just turn on the virtual machines that has the highest critical value, okay, for our objectives. Snapshots and cloning capabilities. We're not talking about virtual machines here. We're talking about the storage server, okay? Just because with the storage server, we can take snapshots of the disks and we can clone the disks as well for instant point in time recovery. So we all understand snapshots and cloning, but basically that gives us a point in time backup. We can use it for testing, we can use it for development, or we can use it for local recovery. So just imagine, I've got all these virtual machines, but I want to do something funny. I want to test this new capability. I don't want to do it on the production servers. I can just make a copy and practice on a development environment. Also, there's capacity reduction techniques such as archiving and deduplication. So if you remember, Son, I know you're the one that did the cert for with me. If you remember, we talked about data deduplication. Remember that? Yeah, you guys heard of that term? Maybe? No?
When you have to remove the duplicates.
Yeah, that's what that's what the term suggests. But basically, let me just give you a quick summary. So with Microsoft Server, we'll just use that as an example. There's a feature called data dedupe or data deduplication, and basically in its storage, it scans for duplicates. Okay, I'll give you an example. If I'm a lecturer here at TAFE and I email you guys a big file, a 20 meg file, okay, and you store it to your network drive. Okay, you all store it at different locations on their network drive. Let's say that I have 100 students, external, internal, and they all have 20 megs, and they store it to the network drive, and they store it into their own profiles. Okay. If we think about it, that's 20 megs times 100 students. That's 2 gigs. But it's 100 copies of it, isn't it? But Alexi might have called it Alexi's file. Reza might have called it Reza's file. Some might call it the songs file, and they're stored here, there, everywhere. Really, they're the same file, aren't they? So what data dedupe does is, if it's all on the same server, okay, if it's all on the same file server, the data deduplication scans through the storage and looks for identical files. We're not talking about the file name identical. You can call it all different names. We're talking about the bit level, the ones and zeros. If they're identical, then they say these 3 files, for example, are identical. Well, I keep 3 copies, I'll keep 1 copy. And then all your locations, wherever they might be, will reference this 1 copy. So that means that 20 gig file, that 2 gig of storage goes down to 20 megs. You see how we're saving 99%, aren't we? 99%, we made a 1% space in that situation. So a lot of these storage servers can have this capacity reduction. So if you take it back to virtualization, if we have 20 virtual machines, they're all server 2019, how much of the things are exactly the same? Very similar, aren't they? If you have a desktop as a service in your private cloud, So VMware Horizons, for example, that's something that's coming in the future for our teaching. That's actually, instead of having a full desktop computer, you might have a thin terminal and you connect to a virtualized instance of your desktop in the infrastructure. If they're all Windows 10, let's say all these labs get converted to desktop as a service. They're all Windows 10. They all spawn from the same clone. So 200 machines here at campus, they're all from the same clone, and they all are virtual machines that are basically exactly the same. So instead of storing each virtual machine like 20 gigs each, like 100 times, we can just store really most of it is exactly the same, aren't they? They also have features like automated data movement from performance, cost, storage tiers. So again, in Cert4, we might have mentioned this. We can have tiered storage. We can have one tier, which is a very fast, high-performing storage, very expensive, like solid-state hard drives. Another one, which is actually another tier, which might be just mechanical hard drives, obviously cheaper, but more capacity. And another tier, which might be compressed for archival purposes. And another tier that's, I might actually have to draw this for you, so to visualize it. So bear with me. So let's do this way. So we might have one tier, which is high performing SSDs. We might have another tier. Oops, wrong one. We might have another tier of just mechanical hard drives, HDDs. We might have another tier, which is still mechanical hard drives, but it's for archive compressed. And we might have another tier over here, which is cloud. All right, so let's get rid of that. So what I'm trying to say is this tier is really fast but expensive. This tier is cheap but not good performing. This tier is bad performance because it's compressed, and it's very cheap because you can have more capacity. And this tier is really just for offsite backups. So what happens then? What happens is that if I have some storage which is being used currently, okay, all the people are using it, it will be sitting here because you get the highest performance, okay? But what if those files, you know how it is, sometimes we all go into the same file because that's the session we're teaching, let's say. Okay, everyone's downloading today's worksheet or PowerPoint. So it's sitting here. But next week, no one's using it. Yeah. So through the software configuration, it will automatically be moved here. Not the location where you see it on your file system, but where physically it's stored, it will move here.
And after a while, it moves to compressed.
Then if no one's using it, it goes to compress, and then really if no one's using it, it goes to offsite storage. Okay, but the software will also know that it's starting to be used. It's getting hotter. Okay, it's so hot, warm, cold storage. Okay, so if the data is getting hotter in the sense that it's actually being used more and more, it will start moving it back as well through the tiers. So what this allows us to do is actually it's a bit of like a hybrid hard drive, isn't it? Where you have some cheap storage and some expensive storage, but when the people are using it, it's actually in high performance. When people are not using it, you're using the cheaper, low performance. So with the automated data movement between the performance and cost storage tiers at varying levels of granularity, so that how the differences. Lungs or local logical units, file system expansion and mobility, which means the reconfiguring of the storage properties dynamically and non-disruptively can be used to add capacity or performance. So this last point is good in the sense that if we have 100 gigs of storage, if we buy more hard drives, we can make it 200 gigs. Do we have to repartition everything? Do we have to delete what we got there, make a new partition? So what it's trying to do is saying we can just add more storage resources to it, and the logical unit file system can just grow dynamically. We can use what's called fin provisioning. If you never heard of the term fin provisioning, I'll give you an example of what VMware Workstation does, because a lot of things can be drawn in comparison. So when we create a virtual machine, oops, not a new window, new virtual machine, you've all gone through this before. We create, doesn't matter these things, but then, oops, go back here. Store this as a single file. Oh, it's not actually allowing me to choose that. All right, let's finish that, and then let's actually add another virtual machine, add another hard drive. All right, so a hard drive, NVMe, create a new hard drive. So this thing here, this checkbox here. So if you tick it, means all the space, the 60 gigs, will be allocated straight away. Okay, so even if it's got nothing on there, it will take up 60 gigs of space. That's what's called FIC provisioning. Okay, if you don't tick this, it means there's nothing used until it uses. It grows when it uses it. That's called fin provisioning. Okay, so fin provisioning means that you can just store as much as you're using right now. It can grow up to 60 gigs. Okay. So you're probably thinking, why would we do FIC provisioning? Well, FIC provisioning is more efficient. It's faster for the virtual machine because it's already got that space. It's there. So if we read this, allocating full capacity enhances the performance, but requires the physical disk space to be available right now, being used. And that's the reason, okay? And that's the same here. FIN provisioning means you're not using all the storage straight away. With our storage architecture, we can also have what's called storage quality of service. So you've probably heard of the term quality of service, which is like prioritization, okay, of some protocols over other protocols through the network. But in this case, storage quality of service means we are prioritizing IOs to deliver a given megabytes per second or IO per second or latency to the particular virtual machine's hard drives. So we can say these are important virtual machines, they get higher priority. Cache memory, so with a storage array, the amount of memory, all have some degree of non-volatile memory. So used for various caching functions. So it delivers lower latency and high IOs per second throughput by buffering the IOs using write caches and storing commonly read data to deliver faster response, and to use read caches. So I think the idea of caches is pretty easy to understand because it's in all computers anyway. But the amount of cache is obviously the more cache you have, the faster your system is going to perform. Cache performance is often used when describing the storage shared storage array performance maximums, IOs per second, megabytes per second, and latency. These are the things we measure. So when you go off and buy a storage server, these are the things you need to consider when you're comparing. So you can, a lot of things you can, like when you buy a car, you can compare, oh, that's got 16-inch wheels and that's got 19-inch wheels. But really, that's not necessarily the most important thing. The most important thing for you, maybe your family is a big one, is how many people you can sit. So in this case, the most important things are these things we need to compare between different storage arrays. Bandwidth, megabytes per second. Performance tends to be more consistent across drive types when large block sequential workloads are used. Sequential means it's all in a row. Okay, so obviously, and that's easier. It's just like you driving down a highway, going straight rather than twisting and turning, going from main road to small roads and so forth. Large SATA drives deliver strong performance at a low cost. Disk drives are categorized by the interface, how they're connected. So fiber channel or serially attached SCSI, SAS, or ATA, serial ATA, SATA. So in your home computer, you're probably more used to the SATA, but in server-grade computers, SAS is a local hard disk. It's a SCSI, so old days it's called SCSI, but SAS is serially attached SCSI, and fiber channel is another way, which is the fiber optics. Drives are also described by their RPM, so this is mechanical hard drives, obviously, and obviously, if we compare it, the fiber channel are capable of a lot faster than SATA, because that's the desktop type. You can see 7,200 RPM compared to 15,000. Yeah, and this one as well. So this is more desktop grade. These are more server grade, but these are mechanical hard drives anyway. So mechanical hard drives are probably a little bit outdated anyway, but they're still good for capacity, good for storage of large amounts of data. EFDs are solid-state hard drives, basically enterprise solid-state hard drives. They have no moving parts. We understand that quite easily. The types and number of disks, as well as how they're configured, is usually the main determining of how storage objects perform. So if we have them in what's a RAID 5, for example, they're going to perform a lot faster if they're single drives or mirrored. Shared storage vendors usually use this from the same vendors, which is quite good, because obviously then they work all exactly the same and it's easy to replace. Quick reference of random read workloads given from a given drive. So, for example, this mechanical hard drives, 7,200, 80 IOs per second. These actual fiber channel hard drives, they're still mechanical though. SATA, SAS, fiber channel, 120 IOs per second. These types, 180 IOPSs. Remember we talked about IOPSs? But if we compare that, this is even older. This slide's a bit old now. But if you look at this commercial, which is what you can buy for your solid-state hard drives for your computer, 80,000 IOs per second. But if we talk about the enterprise flash drives, so these are more like server level SSDs, 100,000 to 200,000 IOs per second. If you compare that to these, you can see how there's a big, huge, giant difference, isn't there? And that's why when we go doing virtualization, if you have a mechanical hard drive versus a solid-state hard drive, as soon as you virtualize two virtual machines, you can tell there's a big, giant difference. And that's what I'm talking about with the IOs per second before. Okay, managing the server array. So let me just, oops, I'll close some of these stuff. It's just in my way here. Yep. So mid to enterprise server storage arrays. So mid-range storage arrays traditionally with dual storage processors, so two CPUs. Cache designs commonly mirror each other. Enterprise storage arrays are those that scale to many. So the mid-range, the enterprise ones scale to many controllers and much larger global cache. Multiple elements can fail in this enterprise while the array is still being used at the very high degree. So basically, mid-range is for smaller businesses, enterprises for large data centers. A hybrid design is such a scale-out design. So in here, with the enterprise, you might have one powerful storage controller and one powerful storage array. But a hybrid design is, instead of having one powerful one of these, you have multiple storage arrays, and scaling up means you have bigger and bigger. Scaling out means you have lots and lots of little ones, but they add up together to give you the same performance. All right, scale out. So scale out designs where they can scale out to more than two storage processors, but without the features otherwise associated with the enterprise storage. So enterprise costs a lot more, but the hybrid will be a lot cheaper. iSCSI only arrays use iSCSI redirection techniques as a core. Mid-range configuration will meet most customers' needs. So, all right, let's look at the storage protocols. Okay, this is where we need to understand some of these things. Okay, fiber channel uses fiber optics. Uses specialized network cards called HBAs. Okay, SANs were initially deployed. SANs were initially deployed to mimic the characteristics of local disk or directionally direct attached storage. So what does that point mean? So when I have a computer and I connect to a storage server through fiber channel, I am treating those disks over there as if they're my local disks. So compare that to a network drive, okay? So when I have a network drive, my computer is saying, I have this file. I need to save this. If you're the server, the file server, I will send my file to you, and you as the file server will say, I will write the ones and zeros in this way. So from the person who's using this, saving it, I do not know what file system you have. I don't care. I don't need to know how to read or write to the hard drive because that's not my job. I just give it to you, you save it. But in another sense, I do not have full control of the files now either, do I? Okay, I do not have full control of the files. I do not know. I'm not in control of how it's written, how it's written and used. So a SAN is a network where the storage devices, logical units, are just like local disks, but they're obviously just far away. So they're treated. So basically, me as the user of this SAN using fiber channel are reading and writing directly to the hard drives, and I control all aspects of it. I don't need another server to control that. So an initiator. So if I'm the ESXi server and Alexi is the storage server for fiber channel, I will have an initiator, HBA, which is a host bus adapter, which is a specialized network card. Okay, and I would be sending instructions through fiber channel protocol to Alexi. Alexi will have a fiber channel card as well, and he will be receiving these instructions and then writing to the hard drives. Okay. An initiator is usually a host bus adapter or HBA or a converged network adapter. So you can actually use a network adapter if you like through a software-based. So if we have a normal network adapter, we have to use a software-based initiator. Software-based initiators are available for iSCSI and fiber channel over Ethernet. So you'll realize today when we do our lab, that's what we'll do. We'll actually use the normal network cards because we obviously can't visualize a host bus adapter, and we don't have a physical network card, which is a host bus adapter for iSCSI. So what we're doing is we're using a normal network card, but we're creating a software initiator in the ESXi to connect to the storage. Fiber channel uses the optical interconnect, so fiber optics, giving a very high bandwidth, low latency, and lossless physical layer. Lossless, like I said, is not susceptible to interference. It's not expecting any losses. Standard fiber channels can support a very high throughput, 4 gigabits per second up to 128 gigabits per second. And obviously, the newer and newer might just increase and increase. So this is just a guide, not an absolute definition. Okay. So you can have it in single, dual, or up to 16 ported options, which basically means you have one. Okay, you're gonna get 4 gigabits per second, one host bus adapter. You have two, you can get 8 gigabits per second. You can have more, you can just increase it. Okay. All right, so if we have this some pictures to help us understand, we have ESXi, we have specialized HBAs, and we use fiber optics to connect. Okay, or we can have in this arrangement where we can connect like this a bit-traded loop fiber connect channel, or more specifically, this is more common. So we have obviously we have a normal copper Ethernet network, but we also have a SAN. Just one second. The SAN stands for Storage Area Network. So it's another network purely for storage. Alexi?
With the previous slide.
Yeah.
How does it work, this arbitrated loop?
This one. This is not in much use, but basically we're using the SAN to actually send the information through this loop in this direction. But this is not so much used. Like I said, this is what we use. Okay. So it's just like in the past, we have many ways, but this is the main way. Okay. All right. So this is what's called a SAN. So it's a storage area network. So this area network, all of these lines are fiber optics. Okay, you can see there's multiple connections. Okay, redundant connections. You even have 2 switches, but these are not just switches, these are fiber channel switches. So they replace the normal Ethernet switches. And then you have the fiber channel array, which usually has a controller and an array of disks. Okay, so with this, we actually are able to access the VMS data store, which is the virtual machine file system data store. And most common fiber channel configuration is a switched fiber channel. So fiber channel switch, SAN, this enables the fiber channel LUNs to be easily presented to the host and creating redundant network as well. Each ESXi has a minimum of 2 HBA ports, and each is physically connected to 2. So basically, if this one breaks, it still can go through this way. That's why it's redundant.
Is that
each switch has 2 connections to this array as well. Reza, you're going to ask?
Is it like a normal like access port for HBA?
No, definitely not. So this is not anything to do with normal computers, okay? Normal desktop computers or access ports for normal computers. This is a high-speed fiber optics where all of these computers are pretty much on the backbone, if you like to think of it. Okay, there's no access level, etc., because this is only reserved for servers. They need access to the storage. Okay, is everyone following me? Son, you okay with what we're talking about here? Okay, so if you like to think of it, this is not your normal network. This is an extra network. It's a SAN, and only computers who need to actually access the hard drives through fiber channel will be on this network. Like your desktop machines, not even close to it. Your desktop machines might be connected to an Ethernet network that is connected to one of these, not these switches, but other Ethernet switches, which has connection to these ESXi, which has a file server that you use. Okay, all right. So your computer wouldn't even get close to this network. So fiber channel uses fiber optics. But like Reza said, it's expensive, it's very specialized, not everyone has experience, and it needs special license just to install it. So what if we, instead of using fiber optics, we just use Ethernet? But why don't we just use the same communication types, but on Ethernet? You get what I'm saying? So that's what fiber channel over Ethernet is. It's actually encapsulating fiber channel communication over the Ethernet. Designed to be interoperable with that and compatible with the fiber channel, the upper layers of the protocol stack, fiber channel and fiber channel over Ethernet looks exactly the same if you like to think of it. It's wherever you use for fiber channel, but they're encapsulated in Ethernet. You understand encapsulation, right? Yeah, all good. Don't need to go through that then, okay? So fiber channel as a protocol doesn't specify the transport physical layer. Unlike TCP and which has retransmission mechanisms to deal with lossy transport, fiber channel doesn't. Remember, fiber channel uses fiber optics, right? And remember, that's lossless, so it doesn't expect any loss. It doesn't expect any losses. But then, if you put on Ethernet, we know that's copper. It is lossy, isn't it? Yeah, that is lossy. We expect sometimes things not to work. That's why in TCP we have the retransmission, okay, error checking and all those kind of things. Okay, so what do we do? Basically, we need a way for dealing with loss and retransmission, and this is why it requires a lossless, jitter-free, high bandwidth physical connections. That's what the fiber channel wants. But to address these requirements, the IEEE created a series of standards to make 10 gigabit Ethernet lossless for fiber channel over Ethernet traffic. 3 key standards is the priority flow control. So I'll be giving priority, enhanced transmission selection, and data center bridging exchange. So these things basically work underneath to replicate what the fiber channel protocol is expecting. So, like I said, encapsulation. So fiber channel traffic, the instructions for reading and writing to the storage array is in here, but then it's encapsulated in now fiber in our Ethernet. What about iSCSI? I stands for IP. We all know what SCSI is. Remember, SCSI is normal old day internal hard drive connection, isn't it? So remember SCSI is small computer system interface. Remember that? We have physical hard drives that we put in a computer with a SCSI connection. But I means IP SCSI, which basically means just like the fiber channel was encapsulated in Ethernet, SCSI is encapsulated in TCP/IP. So these SCSI commands, SCSI instructions, are sent through the normal TCP/IP network. Oh, what does that mean? If it's TCP/IP, it means it's routable, isn't it? But to be honest, I wouldn't route this because it actually needs to be very high speed. iSCSI brings the idea of block storage. So block storage is where we control how we read and write to it. Like we said, the ones and zeros. To customers with no fiber channel infrastructure. So obviously, ideally, fiber channel is what we want. But if we don't have the money, don't have the expertise, we might go with iSCSI because everyone has TCP/IP, don't they, in their network? iSCSI is an IETF standard that encapsulates SCSI controls in a TCP/IP packet. Okay, so again, all of these things. Remember before we said it was a fiber channel switch, fiber optic connections. If we have iSCSI, all of these are just normal stuff now. Okay, normal Ethernet, normal Ethernet switches, and all of this replaces that specialized network that we just talked about with the fiber switches. But exactly the same setup though. And the client computers will never get close to this network either. It's just that this is all interconnected with normal copper, normal Ethernet, and we use normal TCP/IP network, and we're using the iSCSI protocol instead. Not sure about you guys, but unless you're super experienced with fiber, I'm probably thinking, probably this looks more appealing to me, doesn't it? Because it's all the normal stuff I deal with. Normal TCP/IP, normal Ethernet, normal switches, and all the things I have experience with, I can apply here. And that's why people choose this. That's why this is an option. And that's why we use it in our labs today. We will be using the iSCSI option because firstly, we don't have physical fiber channel. Okay. Secondly, we're used to dealing with iSCSI. So we have an iSCSI initiator. So like I said, on the ESXi, we're going to set up an iSCSI software initiator, but you can also buy physical network cards, which are HVAs again, specialized iSCSI network cards, and put in your physical devices. But in our labs, we're going to create software initiator using normal normal network interface cards, and then we use that to connect to a target, which is our shared storage server, which is the true NAS. So if you like to think of it, the iSCSI initiator is the client, the target is the server. So iSCSI initiator is the logical host side device and serves as the same function as a physical host bus adapter. The iSCSI initiator can be software or can be hardware. So ideally in a real life production network, you'll be hardware. In our practice environment, software, okay? But to be honest, if you don't have physical specialized hardware, you can still use the normal network interface cards, just use the software. It just means more processing in the host, which wastes resources that can't be used with the virtual machines. So every time you have a trade-off like that, if you choose software version versus a hardware version, it means there's more overhead on the device, on the host itself. A iSCSI initiator is identified by an iSCSI qualified name, IQN. Just think, you don't need to understand it too much. It's just a whole long string. Instead of IP address, a whole long string. It's a bit like DNS, but it's not something you can read. It's something the host and the server, the host and the target uses. An iSCSI initiator logs in to the iSCSI target. So client logs into the server, basically. The iSCSI target is a logical target side device. So it's on the server, on the storage area network, or in our case, a shared storage server. iSCSI LUNs, remember LUN stands for logical units. So these are basically as if they're hard drives for our host boats over the network, and masked to be specific iSCSI initiators. And iSCSI target is identified by IQN as well. The iSCSI target uses the iSCSI network portal that consists of one or more IP addresses. So you have to have a minimum one, but obviously for redundancy and speed, you can have multiple. iSCSI logical units is a lung hosted by the iSCSI target, and then we connect to it. Okay, what about the security? Everything has security, doesn't it? So we have a challenge response, or CHAP, is widely used basic authentication protocol. So this is the minimum you have to have. But we can also use IPsec. Okay, IPsec, if you can't remember, is an encrypted protocol, and this way it protects against man-in-the-middle attacks. IPsec is relatively rarely used because it is very heavy in CPU. So every time you encrypt, you must decrypt, and that uses a lot of memory, a lot of CPU, which means less resources for your virtual machines. We can use static or dynamic discovery, so we can tell our iSCSI initiators to go dynamically discover what targets are available, or we can manually enter it. Static discovery is used where manual configuration. Dynamic discovery issues a iSCSI standard send target command, and basically this iSCSI target will reply. The target then reports all the available lungs. And there's also a iSCSI naming service, a bit like DNS. It's an ISNS, and which basically resolves those iSCSI names into IP addresses. So all you have to think of it is, I don't need to worry about the names. As long as there is a name, the system will work. All right, so let's look at a picture. I'm not sure about you guys, but me personally, I like to see pictures, because I can, in my head, see what is what. So this is the ESXi server, okay? It has either physical cards, which are iSCSI initiators, hardware, or if these could be normal network cards and you have software initiators. It doesn't matter. But you have two, okay? Because of redundancy and load balancing. All right, so this has an IP address 100. This has 101, okay? Fairly easy so far. So then we actually use the normal TCP/IP network, and with these switches, we're going for two separate switches, and goes to our storage array, which has a storage controller. And this has this IP address, and that has that IP address, two connections again. And then we have these disks, and we'll define the lungs. So when we use the TrueNAS, you'll have a little bit of doing this, where you define the hard drives and define the lungs and define what is available through iSCSI. All right, what about NFS? So we're going to talk about NFS, but this is not ideal. Okay, you should really almost ignore this as an option. When NFS data stores are used, so if you don't know what NFS is, it's network file system. Have you heard of that before? Anywhere else? Song, have you heard of the NFS before?
Yeah.
Where?
In
What operating system? What operating system?
Windows Server.
Windows Server uses SMB, doesn't it? There can be an NFS server as well, but default is SMB. What operating system have you heard NFS with? Anyone? All right, so it's a Linux equivalent. Okay, so SMB is what Windows use for network file sharing. NFS is what typically a Linux server would use for network files sharing. Okay, NFS data stores are usually used by vSphere. There's no local file system such as VMFS, so it's not local disk now. It's a remote disk. So it's a file server. The file system is not on the remote NFS server. This means the NFS data store needs to handle the same access control and file locking requirements that vSphere delivers with block storage using the vSphere virtual machine file system, VMFS. NFS servers accomplish this with a traditional file lock. So this is probably more detail than we need to know, but just think of it, it's not ideal. It's like I said, it's like me telling Razor, write this file for me. I don't have full control. Razor has full control. The movement of the file system from ESXi host to the NFS server also means you do not need to handle any zoning or masking tasks. This makes configuring the NFS data store one of the easiest options. So it's very easy to set up. It's just like I said, it's like in our Windows, we just share a folder. In NFS, we just share the folder. Okay. However, you can't use NFS. It doesn't support high availability or multi-pathing functionality that is normal part of the fiber channel, iSCSI, and other block storage. The functionality has to be provided by the networking stack. So NFS, similar setup, but in a normal TCP/IP network completely, and we're using the NFS to access the data. Again, I know I've said it a few times now, but NFS is not good. It's possible, but it's not good. Okay. So if we actually have a look at this, can our ESXi boot from these type of storage? Yes, fiber channel, no problems. If we have a hardware initiator, because obviously if we have software, it has to boot up, then use the software, right? If we don't, if we have a hardware initiator, then yes, we can boot from iSCSI. NFS, no. We have to use the operating system in order to connect to the NFS server. So if we don't boot, we don't have that operating system. Can virtual machines be connected to these storage? Yes, no problems there. Do we have raw device mapping? So we treat it like a local hard drive. Yes, no. So that's why I'm saying we don't have full control of the block storage. It's not block storage. Dynamic extension, yes. Don't even worry about that. So availability and scaling models, we can use the storage stack. And this one we can use the storage scat. And this one we use the NIC teaming and routing, which is basically your normal practices anyway. VMware features. Does it support vSphere HA, vMotion, storage vMotion, fault tolerance? Yes. So with probably if you had to ask my opinion, in most situations, I'll probably choose iSCSI, except for the very, very largest, very most highest performing networks. Might choose the fiber channel over Ethernet. For the small business, maybe when they don't have a SAN, maybe NFS. Okay, very small business. All right, so that's the end of today.